Hello everyone, I'm Pablo and I'm a computer engineering student in Mondragon University. I'm going to talk about my research article Metamorphic Testing of Autonomous Vehicles, a case study on Simulink. Autonomous vehicles will revolutionize the way people travel by car as they are a complexity of physical systems whose function is to transport passengers safely from a point to another while providing the best quality of service as possible to its users. Testing this type of systems is difficult as it is not always easy to determine which the test outcomes should be, especially those related to QoS measures. For instance, determining the time required by a car to transport a person from a place to another can be extremely complex, and this is known as the Oracle problem. But can metamorphic testing alleviate the Oracle problem of autonomous vehicles modeled in Simulink? We applied MT to testing autonomous vehicles at system level using Simulink. Simulink is the predominant CPS modeling tools and widely used in the automotive industry. To the best of our knowledge, this is the first approach where metamorphic testing is used in the context of Simulink models. In addition, the application of metamorphic testing at system level will allow us detecting more significant safe violations, such as those caused by the vehicle dynamics or uncertainties on the environment. Our approach uses performance as proxy to detect functional errors. This QoS metric has been defined by analyzing the paper by Khangirova at ICST 2021. We determine the effectiveness of our method using mutation testing. Metamorphic testing aims at detecting bugs by looking at the relationship among inputs and outputs of two or more of executions of the program and the test. This is called metamorphic relations. For example, consider an autonomous vehicle getting the function that indicates the travel time from point A to point B by the shortest path. Checking if the output of the system is correct for two random input points will be difficult. This is an instance of the Oracle problem. The order of the parameters should not influence the results unless uncertain occurrences appears. For example, an obstacle when traveling to A to B but not from B to A. In these relations, A and B is the source test case and B and A created by switching the inputs is the follow-up test case. If the relation is violated, the metamorphic test is said to have failed. With careful analysis, the metrics proposed by Khangirova to develop the test oracles for autonomous vehicles, and we selected two of them to specify QoS metrics to be used within our metamorphic relations. The time to destination is the time required for a vehicle to reach its destination, and the trajectory offset is the difference of the lateral position from the start to the end of the driving task. Following these QoS metrics and the test input, we propose different relations for each of the metrics. For each metamorphic relation, a metamorphic relation input pattern has been defined, which describes the input relation between the source and the follow-up test case exploited in different metamorphic relations. Especially, we define the following three metamorphic relations input patterns. The first one is increasing the nominal speed. The follow-up test case is constructed by increasing the nominal speed. When this happens, the time to destination of the follow-up test case should be similar or lower to the source test case, and we can also define something similar to the trajectory offset, as when the speed is increased, the car becomes more difficult to be controlled. Including an obstacle, the second one is including an obstacle in the vehicle's path. In this pattern, the follow-up test case is constructed with an extra obstacle inside the vehicle's path, and when this happens, the time to destination should increase, but the trajectory offset shall not change because the object detection implementation of the autonomous vehicle makes the car to stop. And the last one, swapping the initial and destination points. This pattern represents those metamorphic relations where the initial positions are swapped in the test input. When this happens, the time to destination or the trajectory offsets should not be affected. To assess the fault revealing capability of the defined metamorphic relations, mutation testing was used as it has been demonstrated to be good substitute for real faults. We generated a total of 8 mutants, and the amount of mutants was not large because each test takes a long time to be executed. Notice that, however, the amount of mutation is similar to those used in other testing studies where Simulink models are used. As the results, the first metamorphic relation input pattern gets a score of 68%, and the second and the third one they get a score of 88%. The results show that by combining several metamorphic relations input patterns, we could detect 8 out of 8 mutants. So this suggests that metamorphic testing alleviates the Oracle problem of autonomous vehicles modeled in Simulink. And that's all. Thank you.